Hi everyone, welcome to the online meetup. We're getting underway in just a couple of minutes. All right, cool. I make that 5 o'clock, so let's get underway. So welcome to our latest version of the Neo4j online meetup. So this week we've got Nigel Small. With us is going to be talking, we're going to be doing an introduction to Neo4j bulk drivers. And if you're really interested in this stuff, we're then going to do another session in a couple of weeks' time where we have a few of the driver authors from the community talking about their experience building one of these drivers. So first, Nigel, I guess I'll let you introduce yourself, and I suppose you could start with how you first got into using Neo, and then how you ended up working on the drivers team.
Thanks, Mark. Yes. I came from the community originally, and was one of the driver authors back in 2011, soon after the REST server came out for Neo. Created a Python driver back then, as did along with a load of other drivers that are created in the community, and sort of carried on doing that, and eventually ended up getting a job working here and building some official drivers in a new binary protocol. So that all came out with the 3.0 release a while back now, and we're a few iterations past that, and we've made a bit of progress. And so this is some information on where we are now, where we've been, and where we're going in the future. So, start with a bit of overview. The drivers themselves, they're here to provide a uniform API for Neo users, so that we can provide support across multiple languages. And we tried to start off by looking at the most widely used languages and the ones that the customers are going to find most useful. But we want to venture into other languages going forward. There are obviously community efforts in some of these languages, so we're only going to get bigger in that regard. Why do we build them? Well, the community drivers that sprung up organically had a lot of quite understandable natural variation among how you use them and what features they provided. It was also the case that in the early days, Java, because of the history of the company, was seen as kind of more of a first-class citizen than some other languages. And certainly, if you were a Python user or a .NET user, then the tooling wasn't quite as sophisticated or well supported. There were a lot of type systems to deal with across the board. So Java's type system is very close to the low-level store of Neo. Cypher had its own type system, and JSON, which was used as part of the HTTP offering, obviously added its own complexities at the top level. It is in some ways lossy and not great for representing complex data structures. So that was a problem and a complication. And HTTP itself can be quite verbose in some cases, especially when you're doing a lot of little requests. Sometimes the HTTP headers can be a bit of an overhead. So we had some motivation there to make some improvements. And if we just take a quick look, this was drawn up a while ago. This particular slide near the start of the drivers and protocol project, just illustrating some of the differences between the HTTP and the Bolt approach. So HTTP carried a JSON payload, whereas Bolt was a pure binary payload. Bolt works in a stateful sense on the connection, so we only kind of authenticate once per session, once per connection, that is, rather than once per request. The type system within Bolt is much much more aligned with Neo than JSON is, and overall the requests themselves take fewer bytes. So fewer bytes being transferred over the network means there are many cases where you can get better performance. So we approached the project by focusing very heavily on Cypher, shipping Cypher queries and returning the results from those. We wanted to make a similar experience across all languages, where we thought about the drivers in the same way. We had a similar set of objects and a similar mental model and a common type system that would work across languages. The stored procedures came along at the same time as an extension mechanism that kind of plugged the gap between some of the functionality that you had available in HTTP and some that wouldn't be available at the time in pure Cypher. So stored procedures themselves had a life of their own, and there's probably another whole meetup that we could do about stored procedures. Bolt itself, designed to be fast and low overhead. We wanted to develop key drivers that we supported commercially, and we ended up building a very solid server. It doesn't tolerate protocol misuse, so it's not easy to break it. And we designed the drivers very much with the server functionality in mind, and we've adjusted the server to work along with the drivers. So we've built those two things together. The drivers themselves are all hosted on GitHub. They're all Apache licensed, and they're versioned and released separately from Neo4j. That's quarterly. On average, we're releasing those, although that does vary over time. The drivers can support multiple server versions, and they're the series of drivers that are compatible with a particular series of the server, allowing for easier migrations and upgrades. And we push the drivers to where you'd expect to find them for your particular language ecosystem. The driver version numbers then have a little meaning hidden inside them as well. So the first part, the major version number, aligns with the version of the Bolt protocol that's operated underneath. There's a feature set that's represented by the minor version number, and the patch level, as you'd expect in the patch number. So there have been quite a few versions of the drivers. We actively support four versions of each driver, although that doesn't mean that we can't jump back and pull an old one out if we desperately needed to. But to maintain our own sanity, I think we needed to create a limit around that. So we generally look at 4 versions of each driver. We're currently working on version 1.5, and the current stable is 1.4. All of the 1.x series drivers are designed to work with the 3.x series servers, and therefore the 2.x series drivers will be aligned with the 4x servers. Over the history of this project, we've introduced basic a Bolt driver. We've introduced facilities for supporting causal clustering, where there's routing and load balancing going on. We've introduced several different ways to think of transactions, the best of which and the newest of which is transaction functions. We've added byte arrays, which weren't there in the original releases. They've come in more recently, and we're currently looking at an async API for .NET. So what languages do we support? We've got 4 languages that we've supported since the start internally. We've got Java, Python, .NET, and JavaScript. And by .NET, we generally mean C#, although it does work in other .NET languages quite happily. And here's kind of what it looks like in each of those languages. We've built something that should look very similar in most languages, or at least be semantically very, very similar. So in Java, it's a very straightforward to get up and running with running a piece of Cypher there, logging in with a driver object, creating a session, creating a transaction within that, and running a statement. Similarly, in Python, we can pass in the print names function here into the read transaction method, and we do something very similar in JavaScript and in C# as well. See, there's some similarity, and there's some common naming, some common patterns of usage across all the languages. The general architecture then is that we send Cypher in one direction and parameterize Cypher. So for each string Cypher statement, we also send across a map of named parameters, and we get back out of that a result stream, so a stream of records and some metadata that come back out. And it's a very basic exchange, but it does everything we need to do. All the functionality is built into Cypher or built into a stored procedure that is then accessible through Cypher. So you can do everything you need to do via this channel. Your application will obviously require a Bolt driver, and the server itself has a Bolt server module. So it's a very straightforward architecture. Throughout the process, there's been a bit of a trade-off that we've had to make in terms of working out where we make things uniform across the drivers, so that we can share this common mental model, and where we want to make things idiomatic for the language itself. There have been times where we've gone down one path and we've had to come back and reverse that decision. So, for example, consuming results. When you're iterating through a set of results, in the early days, we developed a cursor-like interface, which we implemented in all 4 languages, and realized at the end of the day that this was going to be quite alien to everybody in every language, because most languages already have an iteration pattern that people are very used to using. So we backed out of that and went down the idiomatic route.
Yeah, the Pythonista in you wasn't happy with yourself.
No, it wasn't really. It was all a bit too wordy for me. So we reversed that decision, and I think that's something we've tried to keep in mind throughout, is that there's a balance to be made between uniformity and idiomatic choices. So within the API itself, there are a core set of objects. There's a driver object. There's a session. The driver itself is the overall template and the way you connect, whereas a session is a context for carrying out some work. The transaction is an atomic unit of work, and the result is something that you can consume from a statement. So drivers themselves have 2 forms, but currently supported. But the forms are exposed through the URI structure. So the URI scheme dictates the kind of driver and the type of driver that you're trying to create, whereas the actual construction of the driver is carried out in the same way, regardless of what kind of driver you're creating. So a direct driver will connect directly to the address that you've put into the URI, whereas in the routing case, that'll merely be the bootstrap address. That's the way into your cluster, and everything else will be discovered from there. But the API itself is designed to not care what your underlying network topology is. You can switch between one and the other, and generally have the same experience. So sessions. The sessions are as I mentioned, the logical context for transactions to be carried out. There's a concept called bookmarking that came in with the causal cluster facilities that we introduced, and this allows us to chain transactions together by picking up a tag that marks a point in the transactional history and passing those from one transaction into another, which gives us the ability to ensure that we carry out transaction A only after transaction B only after transaction A has fully committed, and that does away with some of the complexity of handling the difficulties that we see with eventual consistency in other platforms.
Yeah, and the implementation of that is another one where the design was iterated from the first version, and probably is a much cleaner.
It is, and we've had. There's been times where we've had to throw away things that don't work, and the initial bookmarking setup was a lot more manual for the user.
Yeah, you had to pass it in, didn't you?
You had to pass it. You had to pass in the bookmarks, and I think that added an unnecessary need to know some of the internals that were going on.
Yeah, people were getting quite confused about where they should store the state.
Absolutely.
Now it's still the same mechanism, but hidden away from.
That's it, and we made some improvements to the session itself. So we rethought what the session actually meant, and the session then maintains that state. And actually, if we look on the next page, we mentioned about the state here. This is where it's important to note the sessions aren't the same as connections. In the first release, they were pretty much the same thing. A session was a wrapper for a connection, but they've evolved to this new logical container for units of work. They're designed to be used in a single-threaded environment, and they maintain the transaction state, the ongoing chain of transactions. They maintain a current stream of results, so you can only have one result stream active at a time, but the API will allow you to kind of buffer and store that. And they maintain a failure state as well. So there's a certain amount of state managed there, and that has evolved over time.
So what made you pull those two concepts apart? Was it like a new feature that required it, or was just becoming a mess, treating them as the same thing?
It wasn't flexible enough.
Okay.
So realizing with the clustering work that we needed to route reads in one direction and writes in another, and also that later on we needed to think about retries, and potentially you wouldn't be going to the same machine to retry. You'd obviously go to another machine to retry, because if the first machine failed, you want to go somewhere else. So there was an absolute need to decouple sessions from connections. And now what happens is that if your session is idle for any period of time, you may have no connection associated with it. The connection can go back into the pool, and you can maintain a session without a connection behind it. It means that you need fewer connections to carry out the same amount of
so the retry feature, that was another one that was initially like you had to handle that yourself in your application.
We pushed that out to the end user in the first instance. And then after realizing that a lot of this was predictable, and the way you wanted to handle it, and we pushed a lot of boilerplate code out to users. We tried to re-internalize that whole set of logic, and that's where the transaction functions came from. So I think here we go. So this is an illustration of the different kinds of transactions that you have. The most basic is the auto commit transaction. So that's where you're just running one statement within a transaction, and the transaction begin and commit bracketing will be created for you on the server. The explicit transactions were then the first evolution of the more complex controlled transaction, where you explicitly begin, and then when you end the block, it's committed if all has gone well. But the transaction functions are really where we've added some more magic. So this is where the retries come in. So attached to the session object, there's now a read transaction and a write transaction method that allow you to pass in a transaction function, a lambda that will execute as many times as it needs to within a particular time limit to try to complete successfully. And if it completes on the first go, that's fine. But if it doesn't, the driver itself will seek out another reader or writer from the cluster.
I think again with this one, you went through there were a few designs trying to work out. It's kind of like the idiomatic uniform trade-off again, trying to work out what is the way we can make this so that it's not really alien to like a JavaScript developer or a
and it was, and I'm very pleased with the result. But yes, it certainly wasn't obvious in the first instance, and we had to try some things and undo them and redo them. And where we've settled is nice. It equates a function with a transaction, a unit of work that you can then kind of carry around and repeat as many times as you want in different places within your code. And it actually lends itself very nicely to organizing your code in a very helpful way. So it separates your database logic from your application logic.
Yeah, I've been doing mostly read transactions in a Python application, and it works. It's very nice. Then you just sort of stack up all your functions, and then you just
you can pick them up like any other object, and you can use them. And you haven't got to worry about the complexities of the fact that that's in a database, because that's wrapped up for you. So it is very handy, and it's one of the things I'm most pleased with, I think.
I think I don't think we're going to go into the details of it, but a lot of the things that have been addressed through the different versions of the drivers, with the retries, and then simplifying the architecture you'd have to do for clustering. All of them are trying to make it that deploying your Neo4j applications, I'm sure you've got a machine or some machines, and then the driver is handling a lot of the infrastructure you used to have to do, or the code you have to write yourself.
Yeah, that's it. So we want to make this as easy as possible, as predictable as possible. And the API is not huge. By definition, by design, it's not huge. We want it to be something that's easy to remember. It's easy to just kind of get something up and running. And we want to take away as much boilerplate as possible. You shouldn't have to remember, huge amounts of code, or you have a template project that you need to pull in just to get something up and running. I mean, I've created some demo wiki applications in a few files that, you're talking about 100, 150 lines of code, and it's quite straightforward to do, and it's quite straightforward to look back at your code and actually work out what's going on and re-engineer it. So they're good to work with, and I'm pleased with what we've got to with them. So results then. Results are, we think of them now, we've kind of evolved our thinking. So back pre 3.0, we often talked about the results that came out of Cypher queries as tables, and really they're not. I mean, this is not a table database that we're dealing with here. This is more flexible than that. And I think what was helpful was for us to rethink what we were getting out of these statement executions as a stream of records. It's a stream of objects that just, in this case, happen to be records, happen to be kind of ordered maps, if you like. And in future that can become something else. So we can potentially return any other kind of object in that. We could return single values. We could return whole subgraphs if we wanted to. There's a whole load of things that we could do in that while maintaining the same model, but that doesn't necessarily easily map to a table because we're not limited to tabular thinking. The values within that are then within Bolt aligned very closely to the Cypher type system, and we rethought the type system very, very deeply. We thought about that back when creating 3.0 because of this. The various type systems that are available, and because it was so fundamental to making sure that we transported data accurately, the type system was one of the first things that we tackled, and it's something that we've kind of protected.
So that was the introduction of Bolt the first time where the type system was published, and it previously, like I said, obviously been there, but
it was kind of hinted at in many places beforehand. But depending on, Cypher had its own type system, the store had another type system, and JSON was a third one, and so what we want to do is align across the board, because we couldn't push the Java type system into Python or into .NET very easily because it doesn't translate. So we needed a type system that was universal, and it just so happened that the Cypher type system itself was very, very, very close to what we actually wanted to do.
Yeah, because I think before Bolt, depending how you called it, if you called it like from an embedded API versus from the HTTP API, the types that you get back were often completely different.
Yeah.
So now, obviously, if you use Bolt, then you can
you get a much more predictable set of output. Absolutely. So I've got a few slides here to talk about the protocol itself and how it works. This is going to get quite techie, but hopefully interesting. So within the driver, we can think of some logical tiers. We've got the API that sits on the top. We've got a messaging layer where we're exchanging messages between the client and the server, and then we've got technology called PackStream that we built that sits right at the bottom, and it's a serialization part. So that encodes the messages onto the wire and encodes the type system. The connections maintain a state throughout their lifetime. So after initialization, they fall into a ready state, and they alternate between a ready and a kind of streaming results state, so that you can consume the results and then go back to ready, and so on and so on. And if all goes to plan, you'll never enter fail. But if you do have a failure, then the failed state is entered, and you can get back out of that and back into ready by acknowledging the failure. There's a whole mini protocol around handling failure within that. So at the setup of a connection, there's an initialization phase. We send an identifier to say that we're speaking Bolt. We negotiate the version of the protocol that we're speaking, and we run an initialization message that lets us log in, authorize ourselves to actually use the database. And then if all goes to plan, we can then use run, which is the message for sending Cypher, along with pull all, which is the message for retrieving data back to the client. And there are different ways we can use this. The protocol actually allows us to pipeline this in slightly different ways. So we can, if we wanted to, we could cautiously wait for the response for every message before we carry on to the next one. We could send a few messages at a time. In the steady example here, this is actually what we do in the driver at the moment. We send a run and pull all pair generally when you're executing, and you get back the results of that immediately following. And there's an optimistic batching variant. The protocol allows for this. Could allow you to send a whole batch of runs and pull-alls together all in one go. The important thing to note here, though, is that all of the responses come back in exactly the same order as the requests were sent, and that's guaranteed by the protocol. So it kind of doesn't matter to a large extent when you send the messages out to the server, because you'll always get the responses back in sequence. And then failures, and I mentioned there's a mini failure handling protocol, and it's quite straightforward. In order to cater for the optimistic variant here, where you're potentially batching things, if you send a bunch of messages and one of them fails, it's indeterminate what you should do with the remainder of those. So what we actually do is we ignore them, and we have a special ignored response code, which kicks in if one of your messages, one of your actions fails. And in order to then reset out of that failure mode and to stop things being ignored, the client has to send an ACK failure, and that basically says to the server, yes, I've seen that there's a problem. I've seen you haven't carried out these other things. That's fine. I can resume from here. And assuming that succeeds, which it always should, assuming you're in the failure state, then you can carry on successfully executing more things after that. So PackStream, the serialization format that we put together, it was developed in-house. It was inspired by MessagePack. It evolved quite drastically from that, so it's not compatible with MessagePack, but it does share a few ideas. But we reimagined it in particular, specifically for the Cypher type system, so that we built it with Cypher in mind. And the type system itself has a few basic types, as well as nulls. You can represent booleans, integers, floats, byte strings, and text strings, so Unicode text strings, and a couple of collection types of lists and maps. And then there's an extension mechanism that allows you to implement what we call structures, and the three structures that we implemented here were nodes, relationships, and paths, and they're the three things that you can get out of queries that aren't your typical usual data types. So in the drivers, we actually have custom classes to actually represent these types when you get them out of a query. A PackStream itself, at the very basic level, is just a stream of bytes. But at the start of every PackStream value, there's a marker byte, a single marker byte. And then optionally a size, depending on the kind of marker, and different markers mean different things. And there may be no further content, but there may be a fixed size piece of content. There may be a variable size piece of content. And in the latter case, we'll send the size and then the content itself. So this is a general form of PackStream data. Now, simple values, true, false, and null, are all encoded in a single byte. Integers themselves have varying representations depending on the scale of the integer. So anything that's between -16 and +127 inclusive can be encoded in a single byte. They're very common values to ship around. But anything other than that will then use either 2, 3, 5, or 9 bytes to actually send, depending on the scale. So depending on whether you want to send an 8-bit, 16-bit, 32-bit, or 64-bit integer. And all the integers that are sent around are signed. We don't directly support unsigned. Floats, so they always consist of 9 bytes, a single marker to denote a float, followed by the 8 bytes of the value itself. We don't support 32-bit. And strings are transmitted with a header, some length information. For very small strings, that length information can be embedded in the marker, and then the string data as UTF-8 following that. Lists, similar in many ways. So again, a marker, the number of items as the size in this case, followed by the items sequentially after that. And maps, very similar again, except we're sending alternating keys and values. Structures have an extra piece of information in there, which is a signature, which allows you to specify a type, and as long as that type is agreed between both parties exchanging the data, and in this case the driver and the server, then the meaning can be transmitted. So we have a particular signature for node, for relationship, and for path. But the fields that follow that can be any PackStream value at all. So for example, a node structure actually uses an ASCII N as the signature. It carries 3 fields: the ID, a list of labels, and a map of properties. So where are we going in the future? Well, one of the big questions is what's happening with HTTP. Does Bolt invalidate HTTP? And the answer is partially, but not fully. If you think about HTTP, there's actually more to it than just one batch of endpoints. There's actually a RESTful set of endpoints and a Cypher transactional endpoint. The Cypher transactional endpoint will carry on existing. It is the HTTP equivalent of what we do with Bolt, and there's no plans at all to do anything with that. That said, the RESTful parts of HTTP may be deprecated and removed in 4.0, and certainly the jury's still out there.
Is that the one where you kind of go, you almost do like get a node? It's like, oh, here's all the relationships. Okay, get me that relationship.
It is.
Cool,
it is. It's very
chatty,
good.
Isn't it?
It's very, very chatty. It's good for exploration, but very suboptimal for performance. But it implements all of the RESTful verbs. It's very, very useful in many cases. But we've gone a long way down the road, and I think back when that first came out, Cypher was still a plugin, and now Cypher is far more is far stronger. It's a solid core part of the product. I mean, it's being standardized. There's a whole load of reasons why we need to move in this direction, I think, and the RESTful interface has been incredibly useful. Certainly, it's not a definite that we're going to get rid of it, but it's if anything, it's likely that will be the first thing to go. We're introducing, as I mentioned earlier, async APIs. JavaScript has been quite async since the early days. .NET will be in 1.5 release, which is coming out this autumn. Java.
So what would you expect to see when that one's introduced? Higher throughput on applications?
I think actually it's more about the developer experience. I think okay. people are developing applications that fit with async frameworks, and so it's not a performance thing. The performance isn't too much of an issue in many cases. There are certainly some use cases that we can improve, but in terms of why we're doing it, I think it is largely around integration and fitting in with applications better. We want to come and meet the application to make it easy to integrate.
So this is kind of the idiomatic.
It is. It is about being idiomatic. Absolutely. Absolutely. And our feedback on the .NET side has been that it is very common to use async, an async pattern. And so there's a snippet of code here. We're currently working on this. This is certainly not a final API by any means, but we're exploring what that means. We've done some prototyping. We're working with some partners to do beta testing with us to actually, alpha and beta testing, to actually feed back to us whether we're going in the right direction and how much it helps and so on. But we're certainly going to be introducing that in .NET. Java probably at some point. It's been discussed for Java. No one's mentioned it for Python. So
do we tend to put out early versions of that? If anybody
We can do it, yeah. I mean, we won't do it generally publicly, but if there's someone with a particular need who is interested, absolutely.
So they can maybe ping you on the Slack channel or something.
Yeah, yes, absolutely. We can talk. Getting as much feedback as possible is useful. That we're not building this for ourselves, so as much information as we can get would be great. And then going forward, there's been discussions on flow control and back pressure. And that's something we definitely want to do, but it's not something we can easily do with the protocol in its current form. So
this is I've heard these two phrases when people are talking about building reactive applications. Is that again trying to fit in with that architecture?
It is. At the moment, it's when you run something and you pull back the results, it's a very all or nothing operation, and it's literally all or nothing. You can either pull all or discard all, and the addition of the word all at the end of those messages is actually a hangover from the fact that we wanted to make variants of those that allowed you to pull n or discard n, and you could actually control the flow much more easily and not fill up network buffers just because you can't consume them fast enough. We know we need to do this. We didn't have time to fit it in the original release, so we're planning how we can get that into the next major flip, which will be drivers 2, server 4. We're already doing some background work on what that might look like, but we don't have a delivery date for it yet. It's something that we will deliver, though. We are keen to do that. So yeah, I mean, the example down there says pull. Give me 100 records. Okay, here's 100 records. Now discard the rest.
So it's like if you want to just take the first 100 and then you decide that's enough. Or?
That's one way of doing it. You could also say, give me 100 at a time, and then the server won't generate any more than it needs to. So they're not going to sit in a buffer somewhere. Building paging on an application. Yeah,
or what would be the typical use case for?
Well, there are various use cases for it. I think it's sometimes down to do with how fast you can actually process data on the client side.
Okay. Yeah.
And actually giving the client some control over that flow.
Oh, okay.
Of
so
data.
You might actually want all of them. You just want to control the rate at which you receive them.
Exactly, because otherwise, what's happening is the server's generating all these things and it's trying to transmit them. And if the client can't consume them fast enough, they're going to back up in the network buffers on the way, and you're going to get rejections of TCP messages and so on. Okay. So it's a useful thing to have to maybe overall increase throughput as well, because you're not saturating in the network with unnecessary data and not trying too many resends. So it's being realistic about what you can do, but also saying I only want a few things and I want to throw away the rest. That gives you that capability as well. So there's a lot you can do with it. We want to look at other languages. So there's some directions we can go in. Can we make improvements for other Microsoft languages, for other JVM languages? Certainly, I don't think the .NET driver is necessarily geared up for C++ or F#.
What would you say is missing there? It's like, I guess it's not as idiomatic as.
Yeah, the feedback actually that I've had on C++ is the fact that there are a couple of issues around optional arguments. But certainly things like the functional languages and so on, it's not designed in that way. So maybe we can add some extra layers on top, some extra code examples, and actually broaden ourselves without building a whole new driver, broaden our scope into other similar languages, and the same in the JVM world. So can we do something for Clojure, for example, that is more aligned for what Clojure developers expect, and so on, without building a whole new driver. But then other drivers, Go, PHP, Ruby, they've all been mentioned times as being useful and desirable. There are certainly some fantastic community efforts out there that implement these, but they're not officially supported. Maybe maybe we can bring those in at some point. So that all of that stuff is still open. And then the ecosystem, more widely at the moment, we do have community drivers, and these complement the official drivers. We certainly don't want to kind of destroy. I mean, I was a community driver author myself, and my project's still going. The challenge is trying to work out how the two can sit together, because being asked the question, which should I use? Well, sometimes the answer is obvious, sometimes it's not. I think there's a place for the community drivers to sit alongside and complement the official drivers. The official drivers do provide a kind of fundamental a protocol speaking component, but they don't expose a wide variety of different APIs and functionalities. You can build an OGM on top. You can build all manner of other things on top of the base driver, and indeed the community drivers can also become even more idiomatic than the official drivers, because there's a limit to how idiomatic we can get. We can't necessarily build for every framework and every language feature. Certainly, maybe in Python, for example. We have to build code that works in both Python 2 and Python 3, but there are some things you can do in Python 3 that don't exist in Python 2.
So your favorite subject?
It is one of my favorite subjects to talk about. So yes, we have some community drivers available. Others coming along. If you are a budding driver author, or are just interested in some.
So I guess it could just be you're using a language where you want to use Neo and there isn't one yet.
There isn't one yet, absolutely. And I've spoken to plenty of people who are trying to do that, or want to know whether somebody is already doing it.
Yeah, presumably that was your path to building Python Neo?
It was, partly having too much spare time, and no one else was doing it at the time, or if they were, there were several Python drivers that came out actually, roughly the same time, along with drivers in other languages, in PHP, in .NET, and so on. And I think we all just kind of did our own things just to get ourselves up and running with Neo. And some of them took off, and some of them didn't. And so some projects died when somebody moved on to do something else, or if it wasn't used heavily, and so on. Yeah. So there was a lot of movement in the ecosystem, but that ecosystem is still alive and well, in a different form, but still there. We have a bulk kit repository. This is where we keep a load of tooling that we use, and there's actually a demo driver in there. So it's good. There's a heavily commented demo driver in Python that explains how to build a low-level, simple, direct bulk driver. But we also have other things that we have on our roadmap and stuff that we want to do. We want to release proper protocol specifications. We want some kind of driver certification process in future. And we originally had a TCK that we weren't able to keep to keep up to date. We want to renew that and get that back out again, and provide proper support for those that are building drivers in other languages.
I think at some point a few weeks ago you did like a drivers call. Yes,
that's right. Yeah, we gathered some driver authors, and we all discussed some of the what people were doing, what they were working on, the problems they were hitting, and so on. A lot of it came down to the fact that we hadn't published enough information, so people were having to reverse engineer some of the things that are available. So I certainly took away from that we do need to take even more seriously the publishing of protocol specs and so on.
We've got a question from our chat. Suggestions for using Neo4j with R.
Oh, that's a good one. It's not one that we've actually got on the immediate list to do, although it does keep coming up. So it's worth looking at that. I know Nicole had a driver, didn't she?
There was one on the HTTP.
That was on the HTTP interface. I'm not aware of a bulk driver for R. So if somebody wants to build one, I can happily provide some pointers in the right direction. But no, I'm not aware of one.
But yeah, I guess for now you can probably use the HTTP one if you want.
Yeah, you can use the HTTP interface is still there, and there's, as I say, it's not going anywhere immediately. So that should still work, definitely. So the other things that we've got the language guides on the main website, and there are a few other resources. So there's mailing lists, there's a public Slack channel. And we're available at drivers@neo4j.com if you need to drop us a line there. And that's it.
Cool. Yeah. So I guess if you've got any other questions for Nigel to answer, let us know now or forever. Hold your peace. At least until 2 weeks' time. So yeah, the plan is we'll go back to Thursdays again. So it'll be 2 Thursdays time. We'll have one where we have a few drivers authors and us there as well. We now have a question. So it's from Miguel. Is every new version of the Neo4j server released with a new version of the Bolt Java driver? Is that, and then second question, is that part of the release notes, I guess?
So they're released as separate products. However, the server is released twice a year and the driver is released 4 times a year.
Yeah,
again on average,
they
are more frequent. What we tend to try to do, what we tended toward, is releasing one driver version just before the server version, which is intended to support the features that server's being released with, and another intermediate one. Yeah. So one kind of halfway through the cycle, which obviously helps our development teams, if nothing else, in us being able to provide them with features that they need while they're building the server side of things. So yes, two of them a year should more or less align with the server.
Yeah.
The other 2 will come kind of halfway in between. On
and
average.
So if you're as long as you're within the 4 most recent, and you're not interested in the features of the latest one, I guess you're not obliged to upgrade straight away.
Absolutely, no, you're not. But then on the other side of it, there's very little downside in upgrading. Really, they're all compatible with. They're all compatible with all versions in many ways. So it's only the features you're kind of missing. So you can certainly use I don't know, 1.4 driver against a 3.1 server, or a 1.1 driver against an even newer server if you really want to.
Yeah, and I think you mentioned before we don't ever do anything breaking if it's up to like the 4 and the 2.
Exactly, and that's it. That's what the major numbers. Therefore, we certainly wouldn't expect you to be able to use a 2.0 driver with a 3-point-something server or vice versa. But aside from that, any combination in between, and that kind of gives you the ability to upgrade gradually. Generally, though, we recommend upgrade your driver to the latest version. You'll notice improvements, and there will be hardly any downsides, if any, at all, from doing that.
Cool. Well, hopefully that answered the question, Miguel. I guess if there are, give it a few seconds, but I guess if we don't have any more, next week we've got Nick will be joining us. That's on Thursday. So what's that? The 27th of July. We'll be talking about exploring Belgian corporate networks using Neo4j, and then the following Thursday after that, like I mentioned before, we'll do one with the driver authors. If you like this, so this obviously is a bit more, I suppose, detailed information on how the product is built and some of the nitty-gritty around that. If you like that type of content, let us know in the comments or in the chat, and maybe we can sort out some future sessions. Otherwise, thanks Nigel for explaining Bolt to us.
Thank you, Mark.
And thanks everyone for joining. Bye.